Okay, so we just basically created a new code or just open a new one. I'm just going to copy my stuff across now. So I have my own header and I'm going to use this on there. You can continue working on the same one if you want, but I think I prefer a new one. So again, let's get rid of this so it becomes part of us, yeah? So usual one is what? Pound include, so pound include IO stream has no semicolon at the end, remember that. Then we are going to use the namespace. So we say using namespace. And that has a semicolon at the end. Then we start off with the int main. It's a function. And we leave it like that. And we can return the 0. Yeah? So now we just really want to look at different variables, different data types that go with them. So first, we've already used the double variable definition. We want to look at integer. So we can say integer number, and we will say number is equal to maybe 10. And we just want to print out the value of the number. So we just say copy out the value in number is, and remember in here we can use concatenate, and then we just print number, and then we can end line. So what we have here is also similar to, you can just have a quick look. It's actually similar to doing this. So if I print it out, you see the value in number is 10. It didn't change anything, right? Yeah. So it's pretty much the same. I can just do that. Or I can also do this. So the semicolon just simply means end of statement, which means another statement can start, right? But I'll get rid of that. And then we have a proper concatenation version. The same way from what we've seen before, at the point where we define number, or we declared number, we can actually define it and say, let's say, yeah, let's go with 20, for example. Then we can comment this out, and we have number being equal to that. Are we okay with this? Yeah. We have literals, hello, things, backslash n. I'll give you some time to finalize your code. It's quite similar to previous one anyways. If you've done the previous one in the studio, you get this one. So there are some keywords that you can't use, like these are the reserved words for variable names, right? So I'm going to read through some of the keywords really quickly. Things like align, align of, and, operations, constant keyword, for keyword, friend keyword, private keyword, through, true, false. Like these are the things that normally you use to give the commands or statements in there. Let me use the word command in code, right? So let's see more in terms of what else that we need to use. What works as variable names and what doesn't work as variable names, right? So there are some variable names that are valid and some that are invalid, okay? So let me get rid of this line so that I don't have to edit twice, yeah? To show you some of the variable names that are invalid. So let's start this with underscore. For the variable name, we run it, we don't have an error, right? Let's start the variable name with a number. We run it, we have a number, we have an error. Let's have a two-word variable name. Number is. We run it, we have an error, right? So let's say, capital letter. And remember, C++ is case sensitive. What that means is that we can happily do this as well. And there will be different things. So let's say we copy this out. And then we type number, yeah? So, we give it exactly the same value. Let's make 110. And you notice there are different things, yeah, in the output. So we can use underscore. Sorry?
Like it arranged it.
No, it's the order in which we typed it. We typed the smaller one first.
Oh, okay.
We printed the smaller one first and the bigger one last. So if we can turn it around right now. So let's do this again in terms of valid and invalid names for variables. If you put an underscore in also the word, you have no problem, right? How about special characters like this? Straight away, it's even highlighted them.
Okay.
So it means we're going to get errors with them, yeah? But underscore is not a problem. So how about if we call this, let's say else, int else, we get a problem as well because it's a reserved keyword. So this is also a common question you will get because it just shows you what variables you need to know, how you can name a variable and how you cannot. Okay. So a bit of information, we have different ways we can name a variable. We've got a short integer. This carries maybe 2 bytes in terms of memory space. Yeah, just the short integer. Or you can have, let's say, unsigned integer. What that means is that you've got integer being positive and negative whole numbers, right? So the negative will start from a smaller value to the middle in terms of the amount of byte you can represent. Where you have 0, then it goes all the way to the positive. But if you make it unsigned, then you have 0 to twice as much as the biggest positive number you can have, right? So in the unsigned integer is also 2 bytes. So if you want more storage, that means you have 2 to the power 16 possible combinations, right? The same, you've got integer being 4 bytes and then unsigned integer, unsigned short int, I should say, unsigned short int is the 2 byte, right? Then you have integer being 4 bytes, unsigned integer being 4 bytes, long integer being 4 bytes, then the long integer, or unsigned long integer being 8 bytes, and then of course it keeps carrying on, and it gives you the proper number representation, which I will provide to you for you in the slides. Yeah. So I'm going to quickly write through this particular program, which has shows different variables of different data types. Let me go back. To this point, enable that. Later, I'll save the code for you. And then I'm just going to put here that this program has variables, variables of several of the integer types. So in here, we're going to start with some declarations. So we just say int check-in, unsigned int, mouse long diameter. It's just the different types that we are playing with, okay? Yeah, so we can have, let me make it bigger. I'll save this code for you as well. So you can have the check-in being equal to a negative number, so negative 20. Then we can also have the miles, because it's unsigned integer, we can have a bigger number. We have 4276, maybe diameter as something like 1000.
So long, you should use long.
Long is
instead of
longer.
on side.
Yes. It's really bigger. I can give you the range of numbers because of the 2 to the power combinations. I can give you range of numbers. You can't have a short integer that is bigger than 32,000 unless it's an unsigned. You have an overflow because it's more than the possible number of combinations. Yeah. And of course, I'll just compile it. But if you want, we don't want to play too much. If you want, you can actually copy all of these out, as in print them out. Yeah? Should I do it? I don't think so. You can sort out that one, right? So in terms of terminologies, this is an integer literal, and this is the integer variable, right? Like the literal value of the integer. Yeah. Let me know when you want me to continue. So character is what? Just a letter, right? And it's 1 byte, just 1 byte of memory space. So not too big, right? So we can say char is a letter, and we can assign it as letter is equal to maybe A. It's enclosed in single brace, and it uses the ASCII representation, right? So let's try copy out the value of char. Value of letter is, I'll put that in there. Then run it. So you see the value of letter is A. Yeah? Okay. So you can give it a go if you want. On your side, you can put value of A, B, C, D, and print out. So this is what you should think of a string, right? A string is an array of characters. So if you think of an array, it's like a box containing letters or numbers. So if I have letter is a string, so you have L, right? Then in that string you have, let me find L, then you've got E, then you've got T, then you've got T, then you have E, then you have R. Letter, for example. Yeah. So each of these being a single space is an array, right? But on top of it, it needs to know how it ends, right? The last character. So it actually finishes by the null terminator. The null terminator, right? The null terminator is actually \0. Remember the escape character \n? So every string has the last character being this, right? Of course, it doesn't show, but it's how it's stored in memory. Okay, so this is the idea of the array of characters. So we can include a string in the code, but let's try something. So in here, ideally, the way we've named the data type so far, we've not had a problem unless maybe we get to this particular point where we try to name string. So we have string, call the data type hello, for example. Let's try to compile. We get an error with string. So it doesn't know where string is because string is a special object defined in a special library. So we just have to make sure we include that as well. So we just say pound include, and then we'll use the string library. Now we try to compile it again. The string was not declared in this code unless I've messed it up. It accepts, but let's make sure I did a typo there, but let's make sure that indeed this has an influence. Oh, compiler accepts it anyway, but definitely just make sure you include the string library, okay? So let's have a string as a title movie. So we call this what? Movie title. And we can say cin. Just want to try something. Enter movie title. Which will give us an error. Let's give it a go. See out, enter movie title, and then we will see in the movie. Let's see it. So we say see out. Then just put your movie is movie. So let's run to see how many errors we made. No errors. So let's say Fist of Fury. Your movie is Fist of Fury. Didn't cover the whole thing, but let's see. We can play with it more to see when because seeing is skipping the spaces, but we can play with it more to see when the spaces are skipped. Before we do that, let's, as the weeks go by, we're going to fix it anyway, or in other videos for those who are just watching videos. So let's do this. Let's give this an initial value. Remember, string, you need double quotes, right? This is awesome. And then we print out out movie title. Yeah, sort of makes sense, right? Oops. Are we okay up to this point? In double. Yeah, we've already seen double. Then we want to have a look at float as well. So we can say float, you know, floating point numbers, yeah? The decimal numbers, yeah? So float, my float. And I will assign it maybe 2.3 or 2.5, 2.0. Let's make it 5.0. And then I'm going to have a semicolon, and at the same time, I'll have an integer, my int. And my int maybe will be 2. I'll have another maybe integer, my int 2. And I'll make that maybe 5 as well, yeah? So here, I just want to try out a few things, okay? So first of all, I would just say my int, because it's just a container, we can overwrite it, right? Yeah. I just want to say my int is equal to my int 2 divided by 2. Yeah? My int is equal to 5 divided by 2. At this point, you are just overwriting whatever content is in my int. Yes. Yeah. Okay, so it's not giving us an error. Let's print it out. So we print out my int equals my int. And then we end the line. So first one goes in quote. Yeah. Quote. Oh, wait for the movie. Good. What do you expect the value of my int to be? What is 5 divided by 2? Are you sure it's going to print out 2.5? Hmm? Okay. Why did it print only 2? Hmm? Why did it print only 2? You said something. I want you to say it again. Huh? Say again. It should be float. Right. Okay, let's see. My float 2 equals 2, for example. Or let's call that, let's make this my float 2 so it becomes quite similar. If it were Python, you just simply have to put 5.0 and it recognizes it, isn't it? My float equals my float 2 divided by 2. Right, and then we print this out. I should delete that one. Something. Right, do you see the difference? So the integer only has enough space to store the integer contents that are made for integer. All the decimal points gets truncated or cut off. Yeah? Right. Whilst the floating point works that way. It's interesting. I want to see whether we can have my int 2 divided by this without the points error for it to work. So in order for it to work, you need to have the floating being, because at this point, this is truncated. It's going to be stored as an integer and other things. So for it to work properly, you do have to, sorry, I don't think I will continue the recording. Okay, good. You do have to make sure that the actual number is saved in 0.0 form. Yeah? So let's try with the literal and see. Run it. And this time still doesn't work. Okay? Good. So we're on bool data type, and then a couple of things to in terms of variable initialization and scope, and also arithmetic operators to cover in the beginning of our next session. Okay? Well done, and thanks for staying tuned.
Thank you.